In this video, we will discuss about subtopic 5.2, which is about liquid. At the end of this lesson, students should be able to relate the properties of liquid to intermolecular forces, molecular arrangement, and molecular motion in explaining shape, volume, surface tension, viscosity, compressibility, and diffusion. There are 5 properties of liquid, which is number 1, volume and shape, number 2, compressibility, number 3, diffusion, number 4, surface tension, and the last one is number 5, viscosity. Let's discuss the first properties of liquid, which is about volume and shape. So liquid has definite volume but not a definite shape. Okay, why this happen? So let's focus your attention to this diagram. This diagram shows the arrangement of the molecules in the liquid state. So we can see that the molecules are arranged closely but not rigidly. Means that the molecules in the liquid state still able to move freely. Molecules in liquid state are held together by an intermolecular forces. But why? Liquid has definite volume but not a definite shape. What is the main reason? This happens because the intermolecular force exists between the liquid molecule are strong enough to control movement of liquid molecule. That's why liquid has definite volume. But the intermolecular force exists between the liquid molecules are not strong enough to hold them firmly. This explains why liquid has no definite shape. Let's move to the second properties of liquid, which is compressibility. What is meant by compressibility? Compressibility is a measure of ability of the substance to be forced into smaller volume. As I mentioned earlier, the molecules in liquid state are packed closely but not rigidly. Thus, there is little space between the molecules. So, liquid has low compressibility and much more difficult to compress than gas. For further understanding, let's check out this video.
Fill one syringe with chalk pieces, fill another with water, and leave one syringe empty. Insert the piston and try to compress the material in the syringe. You will see that the syringe with the solids is not compressible because the solids are rigid. The syringe with water is compressible because there is greater space between particles compared to solids. The syringe which is empty is easily compressible because the particles in a gas, in this case the air in the syringe, have more space than solids and liquids. This experiment shows that gas is highly compressible compared to solids and liquids.
Okay, from the video, we can see that liquid has small compressibility. compared to gas. Okay, because the liquid particles are closely packed together and the liquid's molecule have very little space between the molecules. That's why liquid are more difficult to compress than gas. Let's move to another properties of liquid, which is diffusion. Diffusion occurs when molecules move to another region. Like I said before, the molecules are closely packed and liquid molecules cannot move freely from one part to another because the strong attractive force exists between the molecules. Thus, rate of diffusion of liquid are much slower than gas. The stronger attractive force between liquid molecules restrict them to diffuse. Now we move to next properties, which is surface tension. Surface tension is the amount of energy required to stretch the surface of a liquid by a unit area. Molecule within liquid experience intermolecular attractive force in all directions by their neighboring molecules. But molecules at the surface are pulled downward and sideways from the neighboring molecules. This will cause the surface to stretch and tighten. The stronger intermolecular force, the higher surface tension. For more information, let's watch this video.
Why are drops spherical?
Because personally, I'm fond of spherical shapes as compared to squares.
Nah. It is because of surface tension. Surface tension is the property of liquids by which surface molecules of a liquid try to hold the liquid together by acquiring minimum surface area and acting like a stretched membrane.
You know what? Everything just went over my head.
Alright, I'll explain. Inside a drop, each water molecule is pulled with a force by its neighboring molecules. As these forces are equal and opposite, they get neutralized. However, the molecule present at the surface is not attracted outwards. It is attracted only inwards and sideways. Sideways forces get neutralized, but because of the inward force, each surface molecule contracts to form a shape that has minimum surface area, which is a sphere.
The last properties of liquid is viscosity. Viscosity is a measure of liquid resistant to flow. The greater liquid viscosity, the more slowly it flows. At higher temperature, attractive force between molecules become weaker because the kinetic energy is higher. So, viscosity of liquid reduces. The stronger attractive force, the slower the rate of liquid to flow, means that viscosity increase. For more information, keep watching this video until the end.
In the first heat of our race, we have water, rubbing alcohol, and cream. Water finishes first with a time of 0.233 seconds, and rubbing alcohol finishes last with a time of 0.4 seconds. In the second heat of our race, we're going to be racing olive oil, lamp oil, and vegetable oil. Lamp oil finished first with a time of 0.467, and olive oil finished last with a time of 0.633 seconds. In the final heat of our race, we're going to be racing honey, maple syrup, corn syrup, and dish soap. First across the finish line is maple syrup with a time of 1.33 seconds, followed by the blue dish soap with a time of 4.633 seconds. And then slowly but surely, the great corn syrup crosses the line with a 19.5 seconds, and then finally, honey with a 20.767 seconds. Here are the results of our race. Water crossed the finish line first, meaning that it has the highest flow rate and the lowest viscosity. Honey was last across the finish line, meaning it has the lowest flow rate and highest viscosity.